Um, Hello. In this video, I would like to show how to use the soil or unsaturated soil plugin of QAquifolium modeling tool to simulate the long-term infiltration into vadose zone. So, so the first thing I'm going to do is that I will add the soil plugin. So I just go to File menu and then Preferences, and I do click on Add Plugin. I'm using the Linux system, but the full directory structure might maybe a little different than the Windows system. But the default plugins can be found in the executive folder, which on a Windows system is going to be under program files x86, and then you got to go find the folder at which QAquifolium is installed, and then look under resources. In my case, since I'm using the compilation version, um, basically I have it. I have the resources um, in the folder where I have all the um, C++ files. So anyways, I just go here and I pick the unsaturated soil JSON file. I open it. So as you can see, I got some additional components added to my the toolbar right here. So I have one block added, which is called variably saturated soil block, and then I have three links. One of them being a soil to a fixed head connector, a soil to soil connector, and a surface water to soil connector. Today I'm going to use all of these. So the first thing I'm going to do is that I will create this soil column. At this time, I'm going to assume that the area of the soil column is a unit. Basically, it's one. Um, in my case, since I'm only simulating the vertical infiltration, it shouldn't matter. So basically, what I'm going to do first is that I will add a variably saturated soil block right here. So this is what I'm gonna assume. I'm gonna consider the groundwater table to be 2 meters deep, and then I'm gonna use 5 soil elements to model infiltration. So each of the soil elements are going to be zero point 0.4 meters. And now please note that the units that we consider does not matter as long as all our units are consistent. So if I go with uh, foot as a unit for length, then I have to make sure that the hydraulic conductivity value that I'm going to enter is going to be, I don't know, feet per day essentially. So so basically I'm gonna apply the properties to this soil block here, and then I'm gonna make copies of it. So I want to make sure that I will assign all the parameters that I want. I'm gonna keep some of the soil properties as default values, but of course, if you want to apply basically build a model for a real system, you have to be sure to enter the right values for soil properties, soil hydraulic properties, including saturated hydraulic conductivity and also Van Gunington parameters. So the depth of the soil layer, I'm gonna assign 0.4, and I'm gonna have 5 of these that will make 2 meters. I'm gonna assume that the ground surface elevation is 0. Um, so um, then I'm gonna go down from there. So the bottom elevation of the soil block is going to be, in this case, minus zero point 0.4. Uh, the initial storage, keep in mind that if I look at the properties of the soil, let me expand this so that you can see the whole thing. So what I'm going to have is the residual moisture content is 0.05, and the saturated moisture content is 0.4. In this case, basically what we enter is that we enter the initial storage. So we need to enter how much water is in the soil. And I want to pick a value that is between, and that results in a moisture content that is between these values. Now if I have a saturated soil, what I'm going to have is, because the volume of the soil column is zero point 0.4 and then the saturated moisture content is 0.4, I'm going to have 0.16 um, basically cubic meters of water in my system. I'm going to go with a point, let's say, I don't know, let's say 0.1. So the soil is unsaturated. And what else do I need? Now I can point to some of the parameters that you probably need if you want to apply this to a real problem. For example, we need the Van Genegten alpha parameter. We need uh, the Van Genegten N parameter, specific storage, residual moisture content, saturated moisture content, and so forth. But I'm going to keep them as default values because this is just a demonstration case. So now what I can do is that I can just make copies of this soil block. So I'm going to just go here, copy, and then I'm going to paste. So this gives me one soil block. I'm going to copy, paste. This gives me a second soil block. Copy, paste. And then the last one is going to be here. And then of course the only difference between these, I'm going to assume that the soil is essentially homogeneous. Soil layers all have the same hydraulic properties. The only difference is going to be the bottom elevations. So basically for my soil block number 2, the bottom elevation is going to be minus 0.8, and then the next one is going to be minus 1.2, minus 1.6, and then the bottom one is going to have a bottom elevation of minus 2.0. Okay. Now next thing is that I want to connect these soil blocks to each other. Of course I'm going to use this this connector that says soil to soil connector. So I'm going to just connect, and then I'm going to connect that one, and then next one, and next one, right? So I have this soil column. I haven't imposed any boundary conditions, but I can actually run a simulation right now. And what I expect to happen is the initial moisture content is the same in all the soil layers. Since basically I expect to have a downward flow and to get a higher moisture content in the bottom soil block and a smaller in the top one, and I reach some sort of an equilibrium. So what I'm going to do is that I will just run the model. This is going to by default run it for 1 day. Basically, as we move forward with this example, I'm going to just apply some real basically duration simulation. But at this time, I think 1 day may be enough. So basically now I have the simulation done. What I can do is that I can just go and try to see some results. So the results that you can see for the blocks include SE, which is the effective moisture content, storage, head, and theta, which is actually the moisture content. So I'm going to click on, let's say, theta, and what you can see is it's decreasing. It doesn't decrease that much during 1 day. I can actually increase the simulation period, so let me do that. Let me run it for 10 days instead of 1 day. So I'm gonna go to under object browser. I'm gonna look under the setting branch, and I'm gonna click on the general settings. And here what I can do is that basically if I double click on, basically this is simulation end time, and I want to increase it to 10. So that I can do the simulation for 10 days. But if I click here, double click, it's going to provide me with a date box. And that's not what I want to do. I don't want to basically simulate it for over real times. So basically what I'm going to do is that I will just right click, and then this pop-up menu comes up that says insert in numerical format, and I just type 10 here. So that's what I have. Let me just save this work. So I'm going to just save it in my documents. Let's call it soil column and I'm gonna run it. So of course the simulation is going to take a little longer. You can see the time step change during the simulation. I'm going to close this, and now I can look at the results again. So if I look at the data, what I'm going to have is that it's going to go down furthermore. And then I can also look at the moisture content at the bottom column, and as I expect, it goes up. It doesn't reach to a saturation level. Okay, so that's what I have now. And I can also look at the flow. So you can go to results for one of these links. You can see the effective hydraulic conductivity, saturated hydraulic conductivity, effective moisture content, area. I'm interested in flow, so I'm going to look at the flow. And this is what we get for the flow rate. As you expect, it's basically initially higher, and then as the system reaches equilibrium, the flow becomes smaller. So now what I want to do is that I want to apply the boundary condition. So basically what I want to do is that I want to apply a surface water boundary condition at the top, and then I want to apply a fixed head boundary condition at the bottom. The fixed head boundary condition is going to represent, let's say, the groundwater table, and the assumption here is that the infiltration into the groundwater is not going to affect the water table. Now, if I wanted to actually simulate the fluctuation or the change in the water table as a result of infiltration, I had to essentially have some blocks here that represent the groundwater table that have some, their storage can change with inflow. So basically what I'm going to do is that I will add this, so we have this fixed head boundary. So what I'm going to do is that I'll just add the fixed head boundary at the bottom, right there. Move it right here, and then the initial storage shouldn't matter because we have inflow into the fixed head boundary. The head, what I know is that if our groundwater table is at -2, an elevation of -2, the fixed head is going to be -2. Other than that, I don't have to touch anything else. And then I'm going to connect, I'm going to use this connector called soil to fixed head connector to connect the bottom soil block to my fixed head boundary. So now I have my model is changed. What I have is I have so by the way, I said something that I'm going to revise myself. I'm going to put some storage in here. So I'm going to because what I expect to happen is initially when I run the simulation, at least the hydraulic head of the bottom soil block, soil 5, is going to be less than -2. So there will be some backward flow from the fixed head boundary to the soil layer. And if there's no water available in the fixed head block, then that will not happen. So I'm going to put some water in. It doesn't matter how much. I just want to make sure that there's going to be adequate amount of water in the fixed head block. So I'm going to put an initial storage of 1,000, which may look unreasonable, but it's just, it doesn't really matter. So now let me just save this. Just to test this at this stage, I can just run the model right now. So let's see if everything is working fine. So I just ran it. Now let's look at the flow into the groundwater. So I'm going to look at flow, and that's what I'm going to get. So as you can see, the flow is negative. At the end of the simulation, it becomes maybe even not, never becomes positive. But so that's what I was talking about. Essentially, because you have negative pressure, vacuum pressure in the bottom soil block, you have upward flow from the fixed head to the soil block number 5. Okay, so next thing, I want to do this simulation over a long time, and I want to have let's say I want to basically simulate the effect of just precipitation. So what I'm going to do is that I will add a catchment at the top of the system, and then I will assume that there will be some precipitation over the catchment. The precipitation can be accumulated in the catchment and then can infiltrate into the soil. So what I'm going to do is that I will now add a catchment right here. So I'm going to put the catchment right there, and basically let's just assign the properties of the catchment. So we have some properties for the catchment that may not really in this particular case matter, but if I leave, for example, we need Manning's roughness coefficient. If I don't provide them, I'm going to get an error because it's 0 for Manning roughness coefficient is not accepted by the program. There are some criteria that is defined in the plugin that force me to essentially provide a number for Manning roughness. So I'm going to just let's say the Manning roughness is 0.01. I need to provide a precipitation time series, and that's what I'm going to do next. I don't need any initial storage for the catchment. I'm going to assume that at the beginning of the simulation there's no ponded water over the catchment. The area of the catchment is going to be 1, and the mean elevation of the catchment I'm going to keep it as 0, as I should. And so then I think the next step, I'm just going to connect the catchment using one of these surface water to soil connectors. I'm going to just connect the catchment to the soil, the topsoil layer. And it seems like I don't need any properties for the connector. Then I'm going to apply precipitation. So what I'm going to do next is I will just add, there's a precipitation icon here, which if I choose, I'm going to get a precipitation object added to my sources. So for the precipitation case, all I need to provide is a precipitation time series. So I have prepared the precipitation time series that I'm going to show you. So I'm going to go here, click on this block, and then I have a precipitation time series that I've prepared. They are in here. So it's basically some real precipitation data from Baltimore, Washington airport over, I think, in 2012. So I'm going to choose, by the way, let me just show you okay, I can't really, okay, let me just show you the structure of the precipitation data. So I'm going to go to home, it's in my Dropbox, and I got it here. I'm going to open it with text editor, and this is the format of the precipitation data. So we have the data is in CSV format, so it's comma delimited, and then it has 3 columns. The first column is the starting time of that segment of the precipitation data, and the ending time, and then the third column is how much precipitation occurred during that time span, essentially. And the numbers that you see are basically dates. So if you enter this data into Excel or something, and then change the format of the first column, the second column into dates, you're going to see some actual dates. So I'm going to close this, and I'm going to go back to my so here, and I'm going to open that. So, but by the way, you can actually see, you can visualize the precipitation if you right click on this precipitation object and then click on precipitation. It's going to show you the precipitation data translated into flow over an area of 1, right? So you got some data right here. Now what I want to do, if I want to really do the simulation, I have to make sure that the simulation period matches the period that I have data for precipitation. So what I'm going to do, I will click on this again, and then I'll see that the simulation period is over year 2012, right? So it's from January 1st, 2012 to December 31st, 2012. So, and then what I'm going to do is that I'll go to settings, general settings, and then I'm going to change the simulation start time and end time to, so simulation start time is going to be January 1st, 2012, and the end time is going to be, I think, December 31st, 2012. Now let me see. Okay, so the next thing I have to do is that I have to apply the precipitation data that I basically loaded into this source. I need to apply them to the catchment. I have to tell the Aquifolium that this catchment is receiving the precipitation. So in order to do that, I'm going to select the precipitation, and then on this item called precipitation time series, I can just double click, oh yeah, and then just click, and basically my only option is going to be precipitation. This is going to give me a choice over different sources I have, in case I have different sources, or I want to apply different, for example, precipitation to different blocks and things like that. It allows me, but in this case I only have one, so that's the only choice that I have. So other than this, I think all the settings are set. And I'm ready to run the program. So what I'm going to do is that I will just go to this general toolbar up there, and there's this the icon of the gentleman or woman running, and that will run the model. So I'm going to click on that one, and the simulation starts. This is going to take a little longer than our previous simulation because of the fact that it's the simulation is happening over a longer period of time. So we gotta wait until the simulation is over. Okay, 99% and done. So simulation finished. Now let's inspect some of the the results that we're gonna get. So I can check to see if I have any ponding over my catchment. So I can just right click on the catchment block, and then let's look at the water depth. So the water depth, here's a water depth. So we have instances where I got some significant ponding over the catchment. That that results, some of the values may not really make sense. It may be due to the fact that our, I don't know, soil hydraulic conductivity was kind of low, or other parameters that we set in the program. We can look at the infiltration flow. So if I want to look at the infiltration flow, I can just right click on this link right here, and I can look at the flow. So this is going to be our infiltration rate in meters per day, since all our other units are in meters and day. Then I can look at the, let's say, moisture content data in the top layer of the soil. Here's what I have. We can look at the same quantity, the second layer, and let's say the bottom layer. And then we can also look at the, for example, the recharge into the groundwater. So as you can see, it starts with a negative value because there's suction at the beginning, but then it stays positive from that point on. I can look, I can maybe, I may want to compare, for example, the moisture content, the second layer, the first layer. So you just copy this curve and then paste it right here, and that's what you see in case you want to compare them. And that's it for this video. Thank you for watching.